Hello everyone, today is day 43 of solving a LeetCode problem every day, and today I'm going to be solving minimum size subarray sum. So given an array of positive integers nums and a positive integer target, return the minimal length of a subarray whose sum is greater than or equal to target. If there is no such subarray, return 0 instead. And a subarray is just a contiguous non-empty sequence of elements within an array. So in this case our target is 7, and here is our nums array, and our output is 2 because the smallest or shortest subarray with the minimal length that adds up to at least 7 is 4 and 3. Here our output is 1 because our target is 4, and we have a 4 here, and the length of 4 is just 1, so our output is 1. Here in this case, we can never find a subarray which adds up to 11, so our output is 0. So let's get into coding the solution. What I'm essentially going to do is create a window, and this window is going to keep track of whatever our current subarray is, and we're also going to keep track of whatever that sum is for that subarray. And pretty much if our sum adds up or is greater than target, we're going to increment our left pointer in the window. So we're going to essentially just make the window smaller and then kind of look at whatever the next subarray is. And yeah, it's going to make a lot more sense when I start coding it out. But so our left pointer is going to be initialized as 0. And then next thing is we're going to initialize nums needed, which is going to be our output. And this is just going to be the length of whatever nums is, since at most nums needed can be whatever this length is. So that's kind of like our base case. And then current sum is going to be equal to 0. And this just keeps track of whatever the current sum is. And then we're also going to have a has updated variable, and we're going to initialize this to false. And the reason why we have this is because we want to know if this variable right here gets updated at any point, because if it doesn't get updated, that means no subarrays have reached at least the sum of target. So in that case, there is no such subarray, so we just want to return 0 in that case. So that's why we're keeping track of whether nums needed has updated. So now we're just going to loop through whatever the length of nums is, and r refers to our right pointer. Each iteration, we're going to update our current sum with the new value of whatever r is. And then we're also going to check if current sum is now greater than or equal to target. And if it is, we're going to set has updated to true, since now we know at some point our current sum is greater than or equal to target. We're going to also update nums needed. So this is going to be equal to the minimum of whatever nums needed currently is, alongside r minus l plus 1. So our right pointer index minus our left pointer index plus 1. So the reason why we're adding 1 is because right minus left gives us the distance from one index to the other, but the plus 1 just pretty much includes the variable itself. So for example, if we're looking at the distance from index 0 to index 2, that'd be 2 minus 0, which is 2. So we travel 2 places to get from 1 to 4. But if we want to know the length of the subarray itself, then it would be plus 1. So 2 minus 0 plus 1, which gives us 3. And this has a length of 3. And then next thing we're going to do is we're going to subtract whatever is currently at nums at the left pointer, since we're going to increment this left pointer. So since we're changing the window and we're taking out whatever this nums L is, we need to subtract it from current sum to basically maintain this variable right here and make sure that it's valid. So now once we exit this while loop, we're going to check if has updated is true, and if it's true, we can just return nums needed, since we know that at some point the current sum is greater than or equal to target. Otherwise, we just return 0, since it tells us to return 0 if there is no such subarray. So let's submit this, and the solution has gotten accepted. So as for time complexity, the time complexity of the solution is going to be O of n, and the reason why it's O of n is because we're pretty much just processing each well, we're not really doing that, since over here it's going to, I guess, add extra operations, but this solution is going to be solved in linear time, since this isn't going to pretty much impact the time complexity that much. But as for space complexity, that's going to be constant. So if space complexity is constant, time complexity is linear. And then over here in the follow-up, it says if you have figured out the O of n solution, which is the solution using the sliding window, try coding another solution of which the time complexity is O of n log n. I'm not going to get into coding the solution, but I will just mention a couple words about it. Honestly, I haven't taken my own time to solve this in n log n yet, but if I had to imagine how this could be done, what you can do is sort the array, like find some type of sorting algorithm, maybe like merge sort or something that sorts a list in n log n time, and then maybe you could use some type of form of like maybe binary search or something to find the integers you need to come up with this target. Or it could be something like that. I'm not really sure exactly what you would do, but I'm going to assume that this involves sorting the array. But yeah, that's my solution for the day.